So today we're going to be observing several properties of atoms, their ability to emit light. This ability to emit light is because the atom has electrons that reside on specific shells. These shells have different energy levels to where which an electron can go from a lower energy shell to a higher energy shell. By the relaxation from exciting that electron from an inner shell to an outer shell, or from a lower to a higher shell, the relaxation going back forms what we call a photon, or in other words, light. From this light, we can actually depict if it's associated to a specific wavelength. This wavelength can actually depict what kind of color that atom actually emits. For example, if the atom or the substance emits a red color, it corresponds to a wavelength of about 700 nanometers. However, if it emits a green color, then it approximately is 510 nanometers. So by this mechanism of this exciting the electron from a lower energy level to a higher energy level and the relaxation back to its original shell, we can see this emission through a photon, a light. Basically, from here we can determine that with a flame test. This flame test, we can see what kind of color the substance emits, and then from this color corresponds to a specific wavelength. As we can see in the electromagnetic spectrum, we can only see a small portion of it, which is the visible light portion. And the way we can correlate that to a real life scenario is that we can see different colors through fireworks or neon lights. And that corresponds to a specific wavelength that we can see by the various colors on the electromagnetic spectrum in the visible light portion. So before we start the experiment, make sure we have safety goggles as well as gloves, because we are going to be dealing with corrosive chemicals like hydrochloric acid. And if you have long hair, please make sure you tie it back and make sure you have closed-toed shoes at all times and are wearing a lab coat as well. Be sure to dispose of all chemicals properly by their acid or base waste, or either down the drain only if your TA allows it. So the materials that we're going to be using today is sodium chloride, potassium chloride, sodium iodide, potassium iodide, calcium chloride, copper sulfates, barium chloride, and borax. Make sure you just place them in the beakers that correspond to each specific chemical. And we're also going to be using a Bunsen burner because it is a flame test, which is attached to this Teflon tube. And then we're going to be using these wooden splints to basically dip the sticks inside the solution and then light them on fire. Before we start using the Bunsen burner, make sure you have matches or striker to basically light the Bunsen burner on fire. So before we start the experiment, we should light the Bunsen burner on fire. Before we do that, we have to open up the gas line that is connected to the Tygon tubing, and then we light the Bunsen burner with a match. After the Bunsen burner is lit, we can then test out the different chemicals that are displayed here. We're only going to test out 4 of them, which are calcium chloride, copper sulfates, barium chloride, and borax, to see what kind of color they emit, and I will let you try out the rest. So in order for us to see the colors, we're going to have to turn off the lights. So let's see what happens when we introduce calcium chloride into the flame. You can see that it has an orange color. Now we're going to test out copper sulfate. See that it has a yellow, greenish color to it. We're going to do that again so you can see the color. Next, we're going to try out barium chloride. Here you can see that's kind of yellowish. I'll do that again. Next, we're going to try out borax. Borax has many ions in solution, but we're going to see which is the main one when we light it on fire. You can see it's still orange. So definitely sodium or calcium is in there. Since we saw the four different components, or the four different chemicals that emitted different colors, I'm going to let you try out the rest.